So I want to find the maximum value here, and they've already done the hard work for us. They've already graphed and shaded the feasible region and found the corners. All we're going to have to do is plug those corners into the objective function z. So let's do that. We're going to have 2 times 0 plus 8 times 9. That's 0 plus 72 is 72.
Yeah.
We're going to have 2 times 8 plus 8 times 5 is 16 plus 40, or 56. We're going to have 2 times 12 plus 8 times 0, and that's 24 plus 0, or 24. And then, of course, 2 times 0 plus 8 times 0 is just going to be 0. That's not going to be the maximum. The maximum value looks like this number 72. And so to maximize, when we maximize the objective function here, we're going to get a maximum value of 72 at the point 0.09. So then a more realistic question is going to make you do the graphing. You're going to have to do the hard part. And so let's remember how we graph these inequalities. We're using the method of corners, which means we're going to graph it. We're going to find the feasible region. We're going to find the corners. We're going to plug the corners in. I think the easiest way to graph is using the intersect method. So if you look at the first inequality, we want to find the x-intercepts. The x-intercept, it's kind of like if you were making a table. The x-intercept is what you would get if you plugged in 0 for y. And if I plugged in 0 for y, this would go away. And so the x-intercept is going to be 2 times what equals 78. Is 39. The x-intercept is 39. So that's one of the points. I need 2 points to draw a line. That's one of them. And so then I want to find the y-intercept. The y-intercept is like what you would get when you plug in 0 for x. That's going to make this 2x part go away right here. I would have 6y equals 78, or 6 times what equals 78. I give you 78 divided by 6 is 13. And so I've got 2 points. I've got 2 points, and I can use those 2 points to graph my line. And I don't want to make this table. I want to do it in my head. And so I'll just keep it like it's written, with the x-intercept is 39 and the y-intercept is 13. But now I do the other one. If I want to find the x-intercept on my second inequality, the x-intercept is going to be 2 times what is 96? It's 48. The x-intercept is 48. And then the y-intercept is going to be 8 times what is 96? And that's going to be 12. And so I've got 2 points in blue and 2 points in red. I should be able to graph my 2 inequalities. Now, I like that I don't see negative numbers. If I don't see negative numbers, I'm not going to have to graph any negative numbers. And so I'm only going to need the first quadrant. Here's my x, and here's my y. A lot of the times when we're dealing with countable objects like chickens or goats or acres of crops, we're not going to have negative numbers anyway. So we're looking at the first quadrant, and that's it. If you wanted to graph this, you can go by ones if you want. I don't. You could go by tens if you want. Or you could kind of just not go by anything and just eyeball it, and that's what I'm going to do here. If I look at my x numbers, I've got an x-intercept number of 39. I'm just going to kind of place it right here. And I've got another x-intercept number of 48. I'm going to place right here. I'm just kind of eyeballing it. I don't have to be that accurate. Just be neat about it. And then on my y-axis, I'm going to have y-intercept numbers of 12 and 13. I like graphing it in this way. So look back at your blue inequality. The first inequality goes from the x-intercept of 39 to the y-intercept of 13. You've got those 2 points. So let's draw a line between there. The fact that this is an inequality less than. The less than symbol tells me I'm going to end up shading down from there. So I know I'm going to shade down. We'll save that. We'll do that here in a minute. I'll look at the second inequality, the red one. I can see that it's going from the x-axis at 48 to the y-axis at 12. So I'm going to connect those two dots. And the less than inequality tells me I'm going to shade down from there as well. So down from the blue, down from the red. And then, oh yeah, by the way, don't forget these. X is greater than 0 tells me I'm going to be to the right of the y-axis, and y is greater than 0 tells me I'm going to be above the x-axis. And so if you're down from the red and down from the blue, you're boxing in this region right here. Okay? That's called the feasible region. This feasible region, this green region, contains all kinds of points. And all of these points are numbers that would satisfy these inequalities. But we've got a theorem that says if there is a maximum, remember we're trying to maximize, if there is a maximum, we know it's going to be at a corner. So that's why we need to label these corners. This one would be 0, 0. This one would be 39, 0. This one would be 0, 12. This one's the only one that's kind of hard to find. We know how to find it using Algebra 1 techniques or Algebra 2 techniques or graphing calculators or computer. We've got several different methods for finding it. I think the easiest way is to go to a website called matrixcalc.org. You go to matrixcalc.org and go to the system of equations. And our system was 2, 6, 78, 2, 8, 96. I'm going to solve this by Gauss-Jordan. And it'll tell me that my intersection point is 12,9. I can see the intersection point is 12,9 right there. Otherwise, you can do this by Algebra 1 techniques. That's fine. If you had to do this by hand, you do it by Algebra 1. Okay? No big deal. But at this point, I'm back where I was on this problem at the beginning. We've got the feasible region graph, and we've got all the corners. So all we have to do is plug it into the objective function here, 8x plus 3y. 8x plus 3y. That one's going to be 0 plus 36 is 36. 8x plus 3y. Let's use the calculator for that one. We've got 8 times 12 plus 3 times 9. 123. 8 times x plus 3 times y. It's going to be 312. And then, of course, 8 times 0 plus 3 times 0 is going to be 0. So I've got all my corners. I've got my different p-values for each corner. I find the maximum. It looks like this one is the maximum. So the maximum value is 312 at the point 39, 0.